I'm a master's student at the University of Copenhagen, and today I'm going to tell you guys about a project I did on the variation in ovipositor lengths in Darwin wasps. Ichneumonids, also known as Darwin wasp, is the largest family of wasps in the world. They're globally an estimated 60,000 species. And they're also one of the most diverse families of wasps. They range from a few millimeters in size to more than 10 centimeters. So there's a huge variation. Also, all ichneumonids, they are parasitoids. That means that after mating, the female will lay her egg in a host, and then the egg will hatch and the larvae will consume and eventually kill the host in order to complete its larval development. So one of the characters that varies the most in ichneumonids is the length of their ovipositor. And it's been well-recognized hypothesis that ichneumonids who have a long ovipositor, they all have hosts that are inside wood. On the other hand, ichneumonids who have shorter ovipositors do not have hosts inside wood. Now, this hypothesis has been well-recognized for decades, but it's actually never been tested quantitatively. So that's what we aim to do. So we measured the lengths of the ovipositor relative to their metasoma, and then we plotted it on a phylogeny made by Bennett et al. In 2019. And then we also took data on the substrate that their host lived in and plotted that on the phylogeny as well. And I'm gonna just ask if you can see my mouse. I hope you can. Because yes, if we look at the ancestral state, then they have relatively long ovipositors, and down here we have a host shift. So the ones with the long ovipositors, the ancestral state, they have hosts inside wood. At this point, they shift to having hosts that are not inside wood. So that could either be completely exposed hosts or hosts that are hidden inside leaf mines or galls, etc. And we can see subsequently that the ovipositor lengths get shorter and shorter. Now, independently, several times throughout their evolution, they have reverted back to having hosts that are inside wood. So that's marked by these points. And we can see that every time this has happened, they have gotten longer ovipositors as well. Now, we didn't only use the cladogram, we also did a statistical test. So we did a one-way ANOVA, and we could see that the only ones that had statistically significantly longer ovipositors were the ones that had hosts inside wood. We also tested a few other biological factors, which I'm not going to go into great depth with in this talk due to the time constraint, but there were no other really significant results in this. So lastly, I want to thank my supervisor, and if you guys have any questions, feel free to ask.